Hello viewers, in today's session we are going to discuss another very important problem from definite integrals, and in this session we are going to find out the value of this integral, that is from minus half to 0, and we have secant inverse of 1 over x plus 1 dx, right? So we'll see how we can evaluate this integral using two important concepts. The first one is integration by substitution method, and then applying the method of integration by parts, right? So let us first apply the method of substitution to simplify this integrand, and then apply the method of parts. So let us first substitute, say t is equal to secant inverse 1 over x plus 1. So we'll start with this substitution. So now we can write secant t is equal to 1 over x plus 1, right? So secant t is equal to 1 over x plus 1. So let us differentiate both sides with respect to t. So we can now write d by dt of secant t, and here we have d by dt of 1 over x plus 1, right? Now the derivative of secant t is secant t tan t, and here we have d by dx of 1 over x plus 1, and then we can write dx over dt. So by chain rule we have written d by dx of 1 over x plus 1 and then dx over dt. So we can now write secant t tan t, and the derivative of 1 over x plus 1 is minus 1 over x plus 1 square, and here we have dx over dt, right? Now see, 1 over x plus 1 is equal to secant t. So if we square both sides, then we have secant square t is equal to 1 over x plus 1 square. So substituting 1 over x plus 1 square as secant square t, we have secant t tan t, and here we have minus secant square t dx over dt. So now we can write secant t tan t, and we can take minus secant square t to the denominator here, and here we have dt, and here we can write dx. Now this secant t and this secant t get cancelled, so we have dx is equal to tan t dt, and in the denominator we have minus secant t. Now tan t can be written as sine t over cos of t, and here for secant t we can write 1 over cosine t, and here we have dt. Now cos t and cos t get cancelled, so we are left with minus sine t dt, right? So dx can be written as the negative of sine t dt. Okay, so now let us change the limits accordingly. So here we see that the limits of integration vary from x is equal to minus half to x is equal to 0. So when x is equal to half, then secant t is given by 1 over minus half plus 1. So this is 1 over minus half plus 1 is half. So this is 2, right? So secant t is equal to 2. So t is equal to pi by 3, because secant pi by 3 is equal to 2, right? Okay. Now when x is equal to 0, then secant t is equal to, here we'll take x is equal to 0. So we have 1 over 0 plus 1, that is equal to 1. So secant t is equal to t. So it implies that t is equal to 0 because secant 0 is equal to 1, right? So when x varies from minus half to 0, then t goes from 0 to from pi by 3 to 0. So now let us take this integral as I. So I can be written as pi by 3 to 0, and then secant inverse 1 over x plus 1 is t. So here we can write t, and for dx we can write minus sine t dt. So now we have to evaluate this integral. So we can now write pi by 3 to 0, and here we have minus t sine t dt, and we can see that the integrand is the product of two functions. This is a polynomial function t, and this is a trigonometric function. So to evaluate this integral, we'll make use of integration by parts, and the formula for integration by parts is given by integral u dv is equal to uv minus here we have v du, right? So if we can write this integral as pi by 3 to 0, we can write t, and minus sine t dt can be written as d of cosine t, right? The derivative of cosine t. So if we compare t d cos t with this one, then t is our u and v is our cosine t, right? So we have u is equal to t and dv is equal to d cos of t, right? So now we have the formula uv minus integral v du. So uv is t cos t, then we have integral v du, and v is given by cosine of t, and du is given by dt, and the limits of integration are from pi by 3 to 0, right? So we have t cos t minus integral cosine t is simply sine t, and the limits of integration are from pi by 3 to 0. So now let us substitute the limits and taking the difference. So first we'll take t is equal to 0. So here when we take t is equal to 0, this quantity is 0, and then sine of 0 is also 0, right? And then we take pi by 3. So here we have pi by 3 cos pi by 3 minus sine of pi by 3. So here we have minus pi by 3, and cos pi by 3 is given by half, and then we have sine pi by 3, that is square root of 3 over 2. So now we can write it as root 3 over 2 minus pi by 6. Now taking the LCM, we have 6, and then we have 3 root 3 minus pi, right? So the value of this integral is given by 3 root 3 minus pi over 6. So this is how by making use of two important techniques of integration. The first one is integration by parts, and then the second is integration by substitution. We can easily solve these kind of integrals.